given language is a context free language or not. So basic topic here is pumping lemma. So what is the main purpose of pumping lemma? Using this will prove that the given language is not a context free language. Okay, so here we can derive some strings from this language, and if any one of these strings does not belong to does not satisfy any one of the conditions, so we'll pick one string. If that string does not satisfy the conditions, then we can say that this language is not a context free language. So let us solve one example. Let us solve the given example. So how to solve this? First derive strings from this language. So n value is greater than or equal to 1. So minimum string is xyz, then xx, yy, zz, and then xx, yy, zzz, and so on. So let us take one string from this language. Okay. So take the string. So this is how the conditions are given in pumping lemma for context free languages. So if L is a context free language, if this language is a context free, then there exists an integer n. So we need to pick one integer value. Let that integer value be 3. Such that for all z belongs to L. So z means the string which we are taking. So this is our z. For all z belongs to L, so this z should be a part of this language. So we took that from the language only. With mod z greater than or equal to n. So we need to take mod z. So string length is 9. So if it is mod z, you need to take mod z greater than or equal to n. That means xxx, triple y, triple z less than or equal to 3. So if you take the string length is 9. 9 less than or equal to 3. Condition true. So first condition is satisfied. Then there exists u, v, w, x, y which belongs to sigma star. Sigma star means, so sigma is nothing but alphabet. So alphabet which contains symbols. So here you need to select u, v, w, x, y from set of alphabets. Okay. So if sigma is a comma b, then the string should be in the form of a comma b only. Here string is in the form of x, y, and z. So sigma is nothing but x, y, z, and you can have any number of x, y, and z which is represented with sigma star, such that z equal to u, v, w, x, y. So here first you need to divide this string into 5 parts. So if you remember, in case of regular languages, we divided the string into 3 parts for pumping lemma, whereas pumping lemma for context free languages, in this case, will divide the string into 5 parts. So take the given string triple x, triple y, triple z. Divide this into 5 parts. So you can take division in any way. So let it be u, v, w, x, and y. So you can just write it if you want. And z equal to u, v, w, x, y. So z value we divided it into 5 parts, and mod v, w, x less than or equal to n. So find out whether that condition is satisfied or not. What is mod v? Mod v is nothing but x. W means y. X is y. Less than or equal to n value, we already took it as 3. N is 3. So this is nothing but 3 less than or equal to 3. Condition true. So this one also satisfied. Now check the last condition, mod Vx greater than or equal to 1. So what is V value? V is x. X value is y. Greater than or equal to 1. Yes, of course, 2 greater than or equal to 1. Condition true. So this one also satisfied. So for all I greater than or equal to 0, you must prove that this string belongs to I. So this string belongs to this language. So let us take like this. First take I value equal to 0 and u v power I w x power I y. So take the string for this. U means x6, v means x per I value is 0 and w here is y, x is y, x power I, right, 0 and leftover string is y, that is y triple z. So which is nothing but x6, y and this y, z. So check whether this is a part of language or not. So we got 2x, 2y but 3z. There is no such string here. So as it does not belongs to L, we can say that we proved contradiction here, because initially we will assume that this language is a context-free language. Assume CFL. Assume this language is a context-free language. But at the end we prove that this string does not belongs to this language, which is nothing but, as we proved contradiction, it is nothing but this language is not a context-free language. Okay? So this is how we can solve this problem.